Thank you for joining us at NC Center for After School Programs. We're here to do a fun activity called Blueberry and Cabbage Magic. And today what we're going to do is determine the acids and bases of solutions that we make. And the first one that we're going to do is mix a solution of baking soda and water. So you need 1 teaspoon of baking soda. That is the solute. And you need 6 teaspoons of water. 2, 3, 4, 5, 6. Now this is our solution that is a homogeneous, clear, liquid solution, not chemically combined. In our other cup, we have lemon juice. Now we're going to make 2 different indicator solutions. The first of which is simply a leaf or 2 of red cabbage, boiled in the microwave, torn up and boiled in the microwave for 3 to 4 minutes, which then you can pour off. Makes this lovely purple color. That's the known indicator solution. Now, cabbage has a really strong scent, which can be annoying for some students. But the purple in that cabbage is the pigment anthocyanin, which is also in blueberries. So we're going to compare a known cabbage indicator solution with a new blueberry solution. And the best way to do that is to begin by smashing the blueberries. I put about 10 in a bag. Lots of fun for kids. You can see it's almost the same color. Blueberries, of course, do not have that strong cabbage smell. Okay, now you're going to add some warm water to make it a liquid solution, and smush some more. And then you're going to need to strain it out. This is the tricky part. You want the bag almost shut. But not quite. I'm going to strain the liquid. Leave the pieces behind. It's almost the same hue, but not quite. You don't need much. So now we have our baking soda and water, our lemon juice, and a known indicator solution key that tells you whether something is an acid or a base. So let's try. So welcome back. One of the things that we've done for Blueberry Cabbage Magic is we have our known indicator solution made from our cabbage. We have strained our blueberry indicator solution, and we want to compare it with the known solutions of acids and bases. I've mixed my lovely 6-to-1 solutions of baking soda, where I do 1 tablespoon or teaspoon, doesn't matter which, with 6 teaspoons of water. And that gives you a 6 solvent versus 1 solute solution. And now let's see what we get. I've got lemon juice. I've got plain water, and I've got 2 different dropping pipettes. So let's try the cabbage solution first. And this is our known colors for our key for the solutions. So into, oh, that's a good color. You can see it turn green. When you put the purple solution in, it turns a lovely shade of green. Put this up so you can see a little better. See the green? Okay. Now let's try the plain water. Okay, that is definitely not turning the same color. It appears to be more of a blue color. And now let's try our lemon juice. Oh, that's very apparent right away. We get, it turns from a bluish purple into a lovely shade of pink. Now let's compare our known, which says that this is between about a 10 and 11. This one is between a 3 and a 4 on that color. And water is bluish, so right in here, right around 7. And now let's try our known solution of our blueberries. Pouring that in there. It definitely is turning a color. Not quite the same color green. This one's more of a yellowy green. Can you see the difference? That's the blueberry, that's the cabbage. And according to this would make this more like a straight up 12. More from like an 11 to a 12, so this one doesn't read quite the same. But let's go ahead and try the lemon juice. So pouring it in the lemon juice. Oh, it's definitely turning a color. And that color is actually very similar, isn't it, in hue? So when you're looking at this one, this is very close. So right around between like a 2 and a 3, I would say. Very similar. Let's try a neutral and see what we come up to here. Drop a little bit in. I'm going to stir it. Definitely not pink. Definitely not green. Turning kind of a purpley, right between a 6 and a 7 it appears. So we can say that they're similar but not exact. It may be the variety of blueberry that we're using or the concentration of the anthocyanin pigment. So if your kids were really excited about that, they might then take known pH and key out their own blueberry code for acids and bases. But one last thing, there's also an opportunity for a neutralization reaction. When you take an acid and you add a base, interesting things happen. You can see that there's a chemical reaction from the bubbles that are forming. The color is changing. And what's happening is a salt is formed at the bottom. and a new chemical compound is forming, and as are the gases, and you get some water forming. And this is a neutralization reaction. Now you might need some more to keep going. Uh-oh, I might have gone too far, because now I've gone from an acid to about a 12. You can see that? Let's try to get it back. If your goal is to get it to neutral, then you want it to be like a bluey purple color. And you can keep mixing and calculating, if you want to, the solutions until you get to neutral. You can also tell that the scent of the lemon is going away as it's becoming something else. The citric acid is being neutralized. So I think that's kind of a fun thing to do, and all of these chemicals are safe for your kiddos, so it doesn't matter if they decide to eat the chemicals. It's really just soup. Thank you.